Ceramics are a vital part of our lives. They can be found in everything from the cups we drink from to the tiles on our floors. One of the reasons why ceramics are so useful is that they offer a unique combination of physical and chemical properties that are unmatched by other materials. In this video, we will dive into the chemistry of ceramics, exploring their properties and how they are manufactured. At their core, ceramics are compounds of metallic and non-metallic elements. They are formed by heating these compounds to high temperatures, which causes the atoms to react and form new molecules. This process is called sintering, and it results in a very hard and brittle material that is resistant to heat and wear. One of the most important properties of ceramics is their hardness. Ceramics are much harder than metals or plastics, which makes them ideal for use in applications that require extreme durability. For example, ceramic tiles are commonly used in high-traffic areas like kitchens and bathrooms because they are resistant to scratches and wear. Another key property of ceramics is their electrical resistance. Ceramics are excellent insulators, which means they do not conduct electricity. This makes them useful in applications that require electrical insulation, such as electronic components and industrial machinery. Ceramics are also highly resistant to heat. They can withstand temperatures that would melt most metals and plastics, which makes them useful in high-temperature applications like furnaces and kilns. The manufacturing of ceramics is a highly specialized process that requires a deep understanding of material science and chemistry. First step in the manufacturing process is to mix the raw materials. These can include clay, feldspar, and silica, among others. The raw materials are then ground into a fine powder and mixed with water to form a slurry. The slurry is then molded into the desired shape, using a process called forming. There are several different methods of forming ceramics, including extrusion, pressing, and slip casting. After the ceramic has been formed, it is dried and fired in a kiln at high temperatures. This process, known as sintering, causes the ceramic to become hard and durable. In addition to the manufacturing process, the chemistry of ceramics also plays a role in their properties. For example, the addition of certain chemicals can change the color of the ceramic. Iron oxide, for example, can be added to create a red color, while chromium oxide can be added to create a green color. The chemistry of ceramics also affects their thermal properties. For example, the addition of zirconia to ceramics can improve their thermal shock resistance, which makes them more resistant to cracking when exposed to rapid changes in temperature. In conclusion, ceramics are a unique and important class of materials that offer a wide range of physical and chemical properties. Their hardness, electrical resistance, and thermal resistance make them useful in a variety of applications, from kitchen tiles to industrial machinery. The manufacturing process of ceramics is complex and requires a deep understanding of material science and chemistry. Understanding the chemistry of ceramics is key to unlocking their full potential.